Yar! I need to sort all these papers into numerical order, but I don't know how. If only I had someone to help me sort these papers.
Pirate I've never met before.
Is that Tommy Ashfield, the computer scientist?
Why, yes it is. Have you ever tried using insertion sort?
No. But what is it?
Well, I'm glad you asked. Insertion sort is one of the many algorithms dedicated to sorting array lists. The concept was created by John Mauchly in 1946, and it is mainly utilized to sort small lists or mostly sorted lists in general.
Shiver me timbers, that sounds amazing! So where do I start, you swashbuckler?
Well, the good way to start is to start at the start.
So this thingy.
Why, yes, this thingy is going to be considered the first element in our sorted array. And then what we'd have to do is, we'd have to compare it to the next thing, which is the first element in the unsorted array.
This one.
Yeah, and so now you'd compare them. So what would happen?
Well, I like this one better.
Well, it's not just that simple. We compare them to their numeric value in, numbers. So we'd have to, see if 6 is less than 15 to make it sorted. And if it is, we'd have to take 6 and move it to the left of 15.
Oh.
And then this would cause number 6 to be in the sorted array.
Okay. Well, I'm starting to get it now, Sea Dog. But what happens if the number is greater than it?
If the number is greater than 6. Well, that's the fun part, is that once the number finds a number that's less than itself, it just stays there.
Oh, I see.
And then after this, we just keep iterating through all these numbers until we're finally left with our sorted array.
I feel like this is going to take ages.
Well, yeah, it is a very simple sorting algorithm with the worst case runtime be O of n squared. I'm not going to really explain that because you'll find out that later in class. But with the best running case time being O of n.
So it's good with the small stuff.
It's good with the small stuff. That's why it's generally used to iterate through small array lists.
Okay, I'm going to try and sort this now. Thank you.
All right, and while you're doing that, I'm going to do it faster on a computer algorithm, which I will take them over just now. So good luck with that. I'll talk to you when you're finished. Bye-bye. Now moving on to the coding aspect of insertion sort, we have our sorting algorithm. We start by declaring 3 integer variables. Int I, which is the first unsorted element in the array, key, which is the temp variable, thus making this whole algorithm in place because we are able to save the I value and move it to the left. And j, which is the first sorted element within the array. Now starting with the for loop, we have I is equal to the first unsorted element in the array, which is 1. I is less than length, and then we increment. We set key to the array I value, which is the first unsorted. And we set j I minus 1, which is the first sorted, the root. Then we move into the while loop. We check if I is less than or equal to 0, and we have to check if array j is greater than key. Now what this does is, first off, it checks if the sorted element is greater than key, which is, the I. And if this comes out to true, then we will have to go in here and we would have to, first off, since we already have the I element saved into key, we can then, kind of move j over onto that place, and then thus do j is equal to j minus 1, swap places with key, and then j, thus creating your insertion sort algorithm. And then down here, we increment it by just setting j's position in the array to j plus 1. Another thing to talk about is, because we have this greater than, and it's only greater than, that makes the algorithm stable. because if we were to find two variables that were the exact same, we'd have to make sure that we only take the first variable and make that as left as possible, not the second variable, because then that would create confusion and that would not be stable. Other than that, this is the sorting algorithm. Thank you for watching. All right, and now that we're done with that very interesting coding algorithm, we're going to come back to where the pirate is still working on his almost finished array list.
There's a problem. These two numbers are the same. What do I do now?
Well, I'm glad you asked. While being a very simple algorithm, it also looks out for being stable when sorting numbers. So what the issue is that you have two of the same number. Now, how you would determine where these lie within the sorted array list would definitely be, you would have to look to where which number came before the other duplicate.
So this one.
Exactly correct.
So this one goes here.
Correct. And that means that you have finally sorted your array with insertion sort.
I did it!
Well,
yes!
I actually did it faster. Using my computer algorithm, I was able to make the computer do the work for me.
Well, it's my computer algorithm now. Anyways,
No,
thanks.
no, Blair. Wait,
Bye.
it's Blair?
Yeah.
Wait.
Bye.
Hey, that's my code. I need a new partner.